Question 7 involves a skier that is traveling downhill. So downhill would imply that the skier is undergoing acceleration. The value of its acceleration will be less than 9.81. It will be a component of it. Okay, you are told that he accelerates steadily on the hard snow, so the acceleration is a constant here. For the first 5 seconds, and continues his journey on soft snow. Okay, when it's on the soft snow, there will be more friction. So as a result, we will expect the acceleration to drop. Okay, acceleration to decrease. So from this observation, the answer is C. So as we can see from the gradient of the graph in C, in the first 5 seconds, the gradient here is steeper. Then in the next 5 seconds, the gradient here is smaller. So that is to say that the deceleration, that is to say that there is a smaller acceleration in the second half of the journey. Okay, some of you choose the answer as B, whereby you actually assume that the friction on the soft snow is so huge that it causes the skier to decelerate. Well, nothing wrong with that. Okay, so it also depends on how steep the hill is. So in the scenario whereby the hill is not very steep and the snow is very thick, it is possible that the skier actually decelerate. That is, the speed actually decreases. So I accept both B and C. Okay, let's move on to part B. Okay, in part B, you are asked to calculate the average speed of the skier in 10 seconds. So I will do it with respect to C. Some of you recall the equations of motions, and then you use the last one, S equals to half U plus VT. You can't use any of this equation here. Reason being, for the whole 10 seconds, the acceleration is not a constant. Okay, so we can't use the equation. Then how are we going to find the average speed? Recall, average speed equals to total distance over total time. Okay, total time taken, no problem, 10 seconds. But what about the total distance? For that, I will have to find area under the graph. So as you can see, in the first 5 seconds, the area under the graph is the area of a triangle. So I will take half times 5 times 20. That will give me a distance of 50 meters. Okay, then in the next 5 seconds, okay, this is actually the shape of a trapezium. So I will have to use the formula half times sum of the parallel heights. In this case, I have 20 plus 30, then times the base, which is 5. So half times 50 times 5, that will give me 125 meters. So the total distance will be 50 plus 125, and that will give me an average speed of 17.5 meters per second.